This video is for section 1.4 for math 261 applied calculus. We're going to finish example 4 and 5. We're still using the limit definition of derivative, so we have to still simplify the difference quotient before we plug in h equals 0. So we haven't done the power rule or quotient rule, so we're still doing it the longer way. So let's go down to example 4. In class, we worked with quadratic functions and I think one square root function, but example number 4 is a rational function. Where did it go? I copied it onto a blank page. Okay, so use the function to find f prime of x. So we are given f of x equals 5 over 3 plus x. So if I want to find f prime of x, the only thing that we know is the limit definition. So do write down the definition first. Limit of h approaches 0 of the difference quotient. Okay? So we write it down first. And then what we're going to do is we're going to simplify the difference quotient first. And then when we are done, we have it all simplified, we will plug in h equals 0. Okay? So let's set up the difference quotient first. And until you actually plug in h equals 0, keep on writing that limit notation. Okay? So let's find the first part, f of x plus h. So I'm going to plug in x plus h in here. So plug in x plus h right there. So the big fraction bar, I will have 5 over 3 plus x plus h. I will write that down. 3 plus x plus h. So what I just wrote down is f of x plus h. Now what comes after that? Minus sign, right? So do minus. And after that, we need to subtract what? F of x. So write down what f of x is. F of x is 5 over 3 plus x. If you simplify the numerator, I think that's the hardest part when we are dealing with difference quotient. Put the h in the bottom. All right, now we're going to subtract the rational expressions on the numerator by coming up with a common denominator. Okay, so limit. Still write that thing down. Okay. I will write 5 over 3 plus x plus h. It's the first fraction, right? Minus sign 5 over 3 plus x. And I'm going to put their original denominators in parentheses, okay? Let me come up with the common denominator. Now, for the first fraction, I'm going to multiply the top and bottom by 3 plus x, okay? Top by 3 plus x. The bottom by 3 plus x. Perfect. Alright, now going to the second fraction. I'm going to multiply the top and bottom by, this time, 3 plus x plus h. Parenthesis 3 plus x plus h. And the same exact trinomial in the denominator. Okay, so we got the common denominators. And if you're wondering what happened to all over h, well, I was about to write it down, but this is pretty ugly. So what I'm going to do is instead of writing it over h, I will go ahead and draw parentheses around these. Parentheses around these and say I will multiply by 1 over h. Because dividing by h is the same as multiplying it by 1 over h, right? Okay, so let's combine this nasty looking rational expressions, okay? So I will go ahead and write the numerator in a single line. Look, what I'm circling is the numerator, okay? Why not? Let us go ahead and just distribute 2. So I'll distribute the 5, and the same color is confusing me. Alright, hold on guys. I'm going to distribute the 5 to 3 plus x, and instead of distributing positive 5, I know this is subtracting 5, so I will go ahead and distribute the negative 5, okay? So just do it really carefully. So all over, let me draw a big fraction bar, okay? And what we're going to have is 5x, whoopsie, I'm sorry, that's not 5x, 15 first. 5 times 3, 15 plus, and then 5x. All right, let's go to the second part. Negative 15 minus 5x, and then minus 5h. That's looking good. And in the denominator, we just write down the denominator once. 3 plus x plus h, and the other factor is 3 plus x. Doing good. And these are still in a parenthesis. And outside, let me write down 1 over h. Okay. Some things on the numerator should cancel out. If you noticed, there is positive 15 and negative 15. So those are gone. What else? There is positive 5x and there is negative 5x. Those are now gone. And also, just so that I wanna save a line, okay? I don't wanna write this down one more time. Do you notice that there is h on top of the fraction? Hey, hold on. H over here and h in the bottom, right? So that's h over h. So I can cross those out too. So finally, the only thing left on top of the fraction, what's that going to be? What's the only thing left? It is going to be negative 5. Everything else got canceled out. All over 3 plus x plus h times 3 plus x. Now this is simplified enough. Now we're going to plug in, finally it's time for us to plug in h equals 0. My iPad's a little slow. Okay, so finally let's plug in h equals 0. Because we're plugging in h equals 0, I'm not going to write the limit notation anymore. I'm just going to go ahead and plug it in. Negative 5 over parenthesis 3 plus x plus 0, close the parenthesis, and 3 plus x, okay? Do not accidentally plug in x equals 0. H is 0. All right, that can be simplified a little more. So I can say that is the same thing as negative 5 over 3 plus x and another 3 plus x, huh? So guess what? We can write that as negative 5 over 3 plus x squared, okay? So it was a long line of work, but what did we just find? We just found f prime of x, okay? We found f prime of x. So that's what they wanted you to find, so we are done. I can go ahead and maybe just squeeze my answer up here. I can say that f prime of x equals, what was it? The numerator was negative 5 over, the denominator is 3 plus x squared. So we found the answer. This is it. They're not asking us to find the equation of a tangent line at any point, so that's where you get to stop. In, I believe it's section 1.5 or 6, we will learn about a quotient rule. What that is we get to skip this limit definition. We don't have to work with difference quotient all the time. We can use something called a quotient rule to go from the original f of x to f prime of x. But until we learn about those, I want you to practice a couple of these rational functions, and finding their derivative function, okay? All right, so that's it for this video. I will come back for example 5 in just a second.